Okay, I want to start by going over the angle side angle postulate that we looked at yesterday. Right now what I'm going to do is I'm going to go over an informal proof that will prove that triangle ACB is congruent to triangle ECD. Okay, so we're given the information that point C bisects line segment AE. So I want to show you what that means. So I'm going to really identify point C here. So this line segment AE is being bisected. The word bisect means that it's going to be cut exactly in half. So for example, if this entire line segment AE was, I'm just going to say 10, then that means AC has to be 5 and EC has to be 5, okay? Because it's being bisected, so it's being cut in half. So what I can do on my picture to show that those two sides are the same is I could draw a tick mark right there, because that's going to show that my two line segments are congruent to one another, okay? So I could say line segment AC is congruent to line segment EC. And that's by the definition of what it means to bisect. Okay? So then when I'm looking at my triangle, I also notice that at angle C, we have these two vertical angles. So I'm going to show you just by marking those two arcs to show that those are vertical angles. So what that means is angle BCA is congruent to angle BCA DCE. And that's because we have two vertical angles. Vertical angles. Okay. Now, since we're looking at the picture, we also want to look at the sides that are parallel to one another. So it looks like line segment AB is parallel to line segment DE. And the reason I know that is because we have those arrow symbols that indicate that those two lines are parallel to one another. That means that we could look at line segment AE as being a transversal. Therefore, if we look at this angle A and we compare it to this angle E, they have to be congruent because they're alternate interior angles. So I'm going to write that angle A is congruent to angle E. And the reason we know that they're congruent is because they are alternate interior angles. Okay, so what I've just done is I've found these three statements that I'm using to prove that these two triangles are congruent by the angle side angle postulate. Okay, so something that I want to point out here is the reason that this is angle side angle, so I'm going to write this out, that these triangles are congruent by the angle side angle postulate. Now what we're doing is we want to notice here how we're following in order. Here's an angle, right? So that's where I'm getting that letter A from right here. And then when I look here, I have side, my side, because it has that one tick mark. And then I go right here to an angle. Okay, that's my A, the last A. So that's how I know that I'm using that angle side angle postulate to prove that these two triangles are congruent to each other. This is an informal proof. I'm just going step by step to show you one way that you can prove that triangles are congruent to each other. Okay, let's look at what we're doing today. So today you're going to see an example of the angle side postulate. This is the last postulate that we're looking at for triangle congruency. And what I want you to notice with this postulate is that we have two angles, and then this side is not in between the two angles. So when we're looking at this picture, I see here I have an angle, and then as I go through the triangle, I see I have another angle. It's like we want to put our finger starting at one of the vertices and then start to outline the triangle to see what information is given to me in the picture. So if I were to start down here at this vertex, I have angle, and then I go up to another angle, and then I end over here at a side. That's why we're looking at the angle, side postulate. That's one way to tell from the picture. This is a really good picture that helps you look at the 5 triangle congruency postulates. So I would encourage you to write this down, pause, make sure that you're understanding where each of these are coming from. And something that I do want to point out here for angle, side, angle, recognize that that side that's in the middle of the two angles has to be between two angles. That's why it's called angle, side, angle. The order of those letters is important because it shows me what my picture should look like. Okay? And remember that a hypotenuse is the side that's opposite from a 90-degree angle. Okay? This is my hypotenuse. Okay? The hypotenuse is only on a right triangle. Okay, so for example, if I'm looking at this picture up here, I'm going to assume that that's not a right triangle, right? I don't have a little box that's indicating that I have a 90-degree angle. That means that that triangle does not have a hypotenuse. Okay. All right. Now I want to try to show you a little bit of a more formal proof. So let's look at this example. I'm looking at this picture and I can see that I have some given information right here. This information is given to me. And my goal is to prove that triangle FDE is congruent to triangle FTE. So let me go through each of my statements so that we can start proving how these two triangles are congruent to each other. So I have angle D is congruent to angle T. That is given information when I'm looking at this example. So what I'm going to do is I'm going to put an arc on angle D and angle T. That way I'm adding information to my picture so I can figure out which postulate would work best to prove that these two triangles are congruent. The other information that I'm given is that line segment FE bisects angle DFT. Angle DFT is this entire angle right here. Angle DFT. Now, if line segment FE bisects that angle, that means it's cutting the angle exactly in half. So that means that this angle right here has to be congruent to the angle on the other side. So I'm going to put 2 marks to indicate that they're the same size. And then what I'm going to write as my statement is that angle DFE is congruent to angle T, F, E. And the reason I know that they're congruent is because of the definition of what it means to bisect. Sorry, my handwriting is not the best with my iPad. So the reason those two angles are congruent to each other is by definition of what it means to bisect an angle. Okay, now the last piece of information that we have in our picture, just from looking at our picture, is look at this line segment FE. Do you see how line segment FE is on this both of the triangles? It's like both of the triangles share a side together, okay? So that means it has to be congruent to itself, okay? I drew 2 tick marks there just to show that that has to be the same size on both triangles. So I could say line segment FE is congruent to line segment FE. And this is called the reflexive property. The reflexive property. Basically, the reflexive property says that if something is itself, then it has to be the same thing, which sounds a little bit confusing. Let me give you an example. The reflexive property would be like if I say 6 is equal to 6 or 2 is equal to 2, because this is itself. It's that exact number. But let's get back to our picture. The reflexive property in our picture is just showing us that because it's a shared side on both of the triangles, it definitely has to be the same. Now I'm going to say triangle F. Now I've presented enough information to prove that the triangle FDE is congruent to triangle FTE. And if I look at my picture, that's because of the angle, side, angle postulate. Oops. No, it's not. Hopefully you caught that mistake. The reason the angle, side, angle postulate does not work is because the side that we're looking at, FE, is not in between those two angles. So the correct answer that I should have written was angle, angle, side. So if I were to outline my triangle here, I would start here at an angle, and then I'm going across, I see another angle, and then I see the side. That's why I'm looking at the angle, angle, side postulate. Okay, here is an example of 2 triangles that are congruent to each other. I want you to tell me which postulate proves that these triangles are congruent to each other. Okay, if I look at my picture, I have right here an angle, and then a side, and then an angle. Therefore, the best postulate that proves these two sides or these two triangles are congruent to each other is the angle, side, angle postulate. And there's a picture right here. Let's look at another one. All right, so here's another one. In this picture, we have 2 right triangles, and I want to figure out if they are congruent, which postulate proves that they are congruent. And I want you to be really cautious and make sure that you're looking at the picture before you decide. Okay, this one was a little bit tricky because we know that we have a 90-degree angle in our picture. However, that doesn't necessarily mean that the hypotenuse leg postulate would work. The hypotenuse leg postulate works only if we have information about a hypotenuse and then one of the other sides, which would be a leg. But if we look at the picture of these two triangles, there isn't any information about the triangle's hypotenuse. This is my hypotenuse, this is my hypotenuse, and there isn't any information written there. So the hypotenuse leg postulate would not work for this one. Instead, what would work is side, angle, side. Here's another picture of side, angle, side. So the correct postulate that would prove that these two triangles are congruent to each other is the side, angle, side postulate. And let's look at the last one. I want you to look at this picture. Notice we don't have any numerical values. However, we do have those symbols, tick marks, arcs that we can use here. So I want you to look at the picture and then try to identify which triangle congruency postulate would prove that these two triangles are congruent to each other. Okay, so when I look at my picture and I start to outline the information that I have, right here I have an angle, here I have an angle, and then a side. Angle, angle, side. So therefore, the best postulate to prove that these two triangles are congruent is the angle, angle, side postulate. Now, you might be wondering, is there another arrangement of the letters S and A that maybe we haven't looked at yet? So I want to write something down and see if you catch on to this. So I'm going to show you the 5 postulates that we have gone over and that are triangle congruency postulates. So we have side, 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 hypotenuse leg, side, angle, side, angle, side, angle, and angle, angle, side. Okay, there's one more arrangement of these letters that doesn't work. And if you arrange the letters, it forms a bad word. And by the way, this could also technically be written side, angle, angle. It doesn't make a difference because either way it would work. So we just use angle, angle, side to make it less confusing. So maybe you have thought about the last arrangement of the letters S and A, and SSA does not work. And if you look at that the other way, it forms a bad word, right? So maybe that's one way that you can remember that this is not a congruency postulate. And let me show you the reason why. So if I were to have two triangles that have the same side lengths and the same angle, but we're going in that order, I want to show you what could happen here. So let's have a side, angle, and a side right here. Okay, so let's say that this is my angle, and I'm just going to say this is 10, and we'll say that this is 7. Okay, so that would be the arrangement of side, side, angle. The reason that this doesn't work is because if you were to imagine a little pendulum that allows this side to swing to the left or swing to the right, okay? So allow that side to swing, all right? So here's what could potentially happen. Right now, in the position that we have it, it's swung out all the way open to the right-hand side, right? So what would happen if we swing it inward? Okay, I'm going to try my best to draw this triangle. So if we swing it inward, so here's my 10, and I'm going to keep this same angle, right? But now notice what's going to happen with this, the side that's a 7, okay? If I swing it in, it could potentially swing out over here. So notice how these two triangles are very clearly not congruent to each other. This triangle and this triangle, those are not the same triangle. They are not congruent to each other. So the reason that side-side angle postulate doesn't exist is because it doesn't work. It's not reliable. It's not true in every single example. So this is the reason why, because you have this potential for the two triangles to not be congruent. All right, I hope that was helpful.